Assalamu alaikum wa rahmatullah. Good day, everyone, and I welcome you all to our today's physics class. In the previous class, we were able to explain the meaning of electric current as the rate of flow of charges through a given conductor. We were also able to identify ampere as the SI unit of electric current, but we also said that we have some devices that 1 ampere of current is too much. It can damage those devices when it flows through them. So we adopt smaller units such as the milliampere as the unit of electric current, but ampere remains the SI unit. In the previous class, we also identified I equals dq dt as the formula for calculating current. We also say that to calculate the quantity of charge that flows through a conductor after a given time t, we can use q equals it to get that. Now in this class is a step forward. In this class, we will try to identify the types of current we have in physics. Not only identifying, we will also explain those types of current. So we have two objectives only. Number one, identify the types of current we study in physics. Number two, explain them. Let us give it a start. Okay, as you can see, this is usual PHY 1202 electricity and magnetism, the course code and the course title, and under it we are studying types of electric current. Okay, we say that there are two types of electric current. The first one, direct current, and is denoted DC, and then the second one is alternating current. Alternating current, AC. So we have direct current, we have alternating current. Now, let us give the explanation. We have finished with the identification. We identify them as two, direct current and alternating current. Now, the explanation. Here, in the first point here, we are explaining the direct current. We said when current flows in one direction, meaning the current is flowing in one direction only, it is unidirectional. And this flow is either in a constant, meaning it's not changing, the value of the current remains the same, okay, as it flows through, or fluctuating, or maybe it is changing. At one point in time it is high, at some other point in time it is low, okay. That's fluctuating. So it's either in a constant or fluctuating manner, then the current is called a direct current. Remember the point that this current flows in one direction only, regardless of whether the current is constant or it is changing. It is a variable current. Okay, what are the sources of the direct current? These are the currents we obtain from batteries. Okay, if you have a battery has positive terminal and a negative terminal. So if I put connecting wires on the terminals and then I form an electric circuit with an external load, the current I obtain from that battery is DC and not AC, because it is unidirectional, one direction only. This means the current flows from the positive terminal to the negative terminal only. Always the current is from the positive terminal to the negative terminal. It does not reverse direction and move from the negative terminal to the positive terminal. From the beginning to the end, it is always from positive terminal to the negative terminal, and that makes it a direct current. As simple as that. Also, the current we obtain from solar panels. The current we obtain from there is also DC, not AC. And this is why we need an inverter. There is a device they call inverter. The purpose of that inverter is to convert the DC to AC in the solar panels, because some appliances at home need AC and not DC. So you need an inverter to change the DC to AC. Okay? Okay. I think I have to show you in diagram. Okay, in diagram, let's say this is the positive terminal of a battery, and this is the negative terminal. This is positive, this is negative. Now I have connecting wires here. Okay, now then I connect load here. This is load. It can be anything connected in an electric circuit. It can be a resistor, it can be electric bulb. Okay, any device you connect in an electric circuit. Now this is my battery and this is my load. Okay, and this is my connecting wire. Okay. So in this situation, current flows from the positive terminal, you see, from the positive terminal to the load and back to the negative terminal. The process is repeated again and again, again and again, again and again, okay, until it is disconnected. When this happens, we say that this current is a direct current, abbreviated DC. Now, on the other hand, look at what we have here. On the other hand, when current flows in two directions, you see, two directions, alternating, they are changing, okay? Alternating, the current is called an alternating current. Okay, we need a diagram to explain that. Let's say this is a positive terminal of a battery and this is the negative terminal of the same battery. So I have a battery, as usual. I'm going to show you here using a battery, but remember, we do not get AC from a battery, but it's a good start to show you how AC works. Okay, now look at it here. Let's say I have my connecting wire and this is the load. This is the load. Okay, great. Positive terminal, negative terminal. Now, if it is AC, at this positive terminal, it is 0. The value of the current is 0. Then the current flows in this direction and the value is increasing until it reaches a maximum value that we call I naught. I naught means peak current. Peak current. Peak value of the current, meaning the highest value you can have for that current. After reaching this peak value, it will now begin to drop again, and when it reaches the negative terminal, it is 0 again. You see? Now, upon reaching this negative terminal will automatically become positive. It will become positive terminal, and then the positive terminal that you have initially will now become negative terminal. So there is alternation in the terminal. The terminal that was initially positive becomes negative. The one that was initially negative becomes positive. When this happens, the current reverses direction. It will not flow in this direction again. It will not flow this way, and it will start from 0 again, and then it will reach a maximum value. It will be increasing as it flows and reaches a maximum value I naught, same as this one, but we give this now a negative value to indicate that now the current is flowing in the opposite direction. That's the meaning of the negative here, but it has pretty the same value as this. Okay, when it reaches this maximum value, it will now begin to drop again, and then upon reaching this terminal, it will become 0 again. When it reaches the negative terminal, the negative terminal will now become positive terminal, and then the positive terminal become the negative terminal, so that the current can reverse direction again and flow in the opposite direction. You see that? Increasing in value, dropping, and then alternating. When it flows this way, it goes back again. It flows this way, it goes back again. Okay, and the terminal here, at one point, this is positive, this is negative. When it reaches again, this terminal will alternate. So there is no terminal that is permanently positive, and no terminal is permanently negative. For this reason, we don't use this symbol for AC source. Okay, what we use is something like this. You see, this one. Wow. You see, wherever you see something like this, you know that the current you obtain from here is an alternating current. It's not a direct current. Okay, these are the current we obtain from generators. If you are using power generator engine, okay, these current obtained from them are AC and not DC. Okay, wow. Oh, another symbol we use is something like this. Okay, you can either use this or this as the voltage source for the current. Okay, to sum it up, let us give a quick summary. We have two types of current. Okay, types of electric current: DC and AC. If you take DC, DC flows in one direction, okay, only, whether it is constant or fluctuating, and we obtain DC from batteries. Okay, then we have AC. For AC, we have a current flowing in two directions. No terminal is permanently positive, and no terminal is permanently negative. When current flows this way, it reverses direction and flows the other way. And as it is flowing, the value of the current increases to a maximum value, then drops to zero, then it reverses again and increases in the opposite direction to maximum value, decreases to zero, and on and on. Okay, so this is all we have today for you, and I hope it is pretty clear to all of you. Thank you for watching. Assalamu alaikum.